In this video, we're going to work on generating equivalent expressions, and we're going to focus on combining like terms. So here in this picture, we have a bunch of popcorns and a bunch of movie boards. So we're going to combine the same things together. So we'll count the popcorns. So we've got 14 popcorns. And then we will count the movie boards. And we have one, two, three, four. So now we've combined that we have 14 similar popcorns and 14 similar, or excuse me, four similar movie boards. So algebraic terms can be combined in a similar manner as what we just did with the popcorn and the movie boards. Remember that a term is either a single number or variable or numbers and variables multiplied together. So like terms are terms whose variables and their exponents, such as 2 and x squared, are the same. So let's take a look at that. So this first picture here, we're going to combine or count how many x squares we have. So we're looking for anything that has an x squared along with it. So here is 1, and that looks to be the only one. So we're just going to put a 1 here. Now, the next thing we're going to look for is those things that just have x's. So we're looking for things similar to this. So here's 1, 2, 3, and 4. And now we're going to do the same thing, but this time we're looking for those things that have y's. So similar to this right here. So here's 1, 2, 3, 4 that have y's on the end. And then our last one here, we're going to take a look at the ones that just have the constants or just the numbers. So here's 1, 2, 3, 4, 5. So now let's take a look at this problem and do a very similar thing. So the first thing we're going to do is we're going to look for like terms, or in this case, terms that all have these x's on the end. So I have 14x here, and then I also have x here. So I have a negative 8x because this subtraction problem or this subtraction sign goes along with that 8x. So here I have 14x minus 8x, which gives me a total of 6 x's in my problem. And then I'm also going to look for ones that have the y. Well, here's a plus y, because again, this plus sign goes along with it, and that's all I have. So in this problem, I just have 3y. So when I write my simplified term, or excuse me, my simplified expression, it would be 6x plus 3y. And now to prove that those two are the same, we're going to substitute 2 and 3 in for my variables. So here I would have 6x plus 3y, which is this one right here. And so then that would be 6 times 2 plus 3 times 3. 6 times 2 is 12. 3 times 3 is 9. And then when I add those two together, I get a total of 21. And then I want to look at my other one, which is right here. And so here I have 14x plus 3y minus 8x. So again, I'm going to put the 2 and the 3 in for my x's and y's. So this would be 14 times 2 plus 3 times 3 minus 8 times 2. Well, 14 times 2 is 28 plus 9 minus 16. This gives me a total of 37 minus 16, and 37 minus 16 is 21. And we're going to notice that this 21 and this 21 are the same. So that means that these two equations are exactly the same. They are equivalent. Let's take a look at this one. So again, my first one here is the x. So I'm going to look for all of those that have an x on the end. And in this case, I have 5x. And again, this addition sign has to go along with that 5x. So I would have 16x plus 5x, which gives me a total of 21x. And I still have some things left in the problem. So I'm going to look here, and I have a minus 9, because again, the subtraction sign is going to go along with the 9. So that gives me a minus 9. So my simplified equation then would be 21x minus 9. So again, let's take a look at this and show that these two are equivalent. So again, I'm going to put 2 in for x. So in this case, I would have 21 multiplied by 2 minus 9. 21 times 2 is 42 minus 9. 42 minus 9 is 33. And then if I use my original equation, or excuse me, expression, I would have 16 times 2 minus 9 plus 5 times 2. Well, 16 times 2 is 32 minus 9 plus 5 times 2 is 10. 32 minus 9 is 23 plus 10. 23 plus 10 is 33. So again, I see that this 33 and this 33 are equal. So that means these two equations are equivalent. So here we have 18r plus 7q minus 11r plus 13q. So again, first thing I'm going to do is look for the r's in the problem. So here I have 18 groups of r, and here I have 11 groups of r, but that subtraction sign goes along with it. So I would have 18r minus 11r, and that gives me a total of 7r. And then we'll look for our next group, and that has q's with it. So again, I have plus 7q because the addition sign goes along with it. And then again, plus 13q because again, the addition sign goes along with it. And 7 plus 13 gives me a total of 20q. So my simplified expression would be 7r plus 20q. So again, I put the r for 2 and the q equals 3. So when I do that, I would have 7 times 2 plus 20 times 3. 7 plus 2 is 14, plus 20 times 3 is 60. And when I add those two together, I get a total of 74. And then when I do the same thing with my original expression, I would have 18 times 2 plus 7 times 3 minus 11 times 2 plus 13 times 3. And when I work through that, this gives me 36 plus 21 minus 22 plus 39. 36 plus 21 gives me 57 minus 22 plus 39. 57 minus 22 is 35 plus 39. And 35 plus 39 gives me 74. And so again, I notice that this is 74. This is 74. So my two equations are equivalent. Here we have 4x squared plus 14x squared minus x. So again, first thing I'm going to look for are my groups of 4x squared, or excuse me, just x squared. So here's 4x squared. Well, here's plus 14x squared. And again, remember that that plus comes along with it. So I then would have 4x squared plus 14x squared. And that gives me a total of 18x squared. And then I still have some things left, so we'll take a look at those. And I have just an x here, and so it would be minus x. And so my new equate or my simplified expression would be 18x squared minus x. So again, I can put a 2 in for x to see that they are equivalent. So I would have 18 multiplied by 2 squared minus 2. So this would give me 18 multiplied by 4 minus 2. 18 multiplied by 4 gives me a total of 72 minus 2. And that then would equal 70. If I put in my original, then I would have 4 multiplied by 2 squared plus 14 multiplied by 2 squared minus 2. 4 multiplied by 4 plus 14 multiplied by 4 minus 2. This gives me 16 plus 56 minus 2. 72 minus 2 and 70. So again, 70 equals 70. So that means that these two expressions are equivalent.